guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. And this has been a horrendous day, but I gotta keep going. M4v. Let's do the intro on this thing. Just looking at this roughly, I can tell you there's a few things in here that are not right. Somebody has obviously done them. They figured out that if you bypass the fuse, it's going to pick up its output. None of this is right. These are all wrong. Somebody's gone in here. The value might be correct as far as its capacitance level, but its kVA rating is wrong. And so we've got to figure out what they've done. This has also been modified. This is our output tune. That's part of it. It's the first half, and then you got an induction coil, a pi and an L. That's its output capacitance. The input driver on this thing has been completely bypassed. I am not going to repair this. Had a guy call me tonight. I'm pretty sure he's going to pick this up tomorrow from me. I do believe that this whole section here can be bypassed and completely deleted if we needed it to be, but somebody has already gone. If we follow this coax around, they literally chopped it off at the driver board down here, brought that coax around very haphazardly, pigtailed the coax, and brought it to our input. There is no capacitance tuning from here to there. How this works is the capacitor or the coax RF comes in, goes through this series, this resistor bank, comes back out, and then we've got our variable tuner. The input tune on this box will be horrendous, absolutely horrendous. On the upside, the biasing circuit's still in play. So, first things first though, this thing is disgusting and filthy. So I will pull the power wire out of it, and then I'm going to take and wash it. When I come back, that'll be post-wash, and then we're going to start putting the right parts back in it and see if we can get this thing to run. I shall return. All I'm going to say is it pays to have friends. Last night, texting back and forth with a buddy of mine, he asked me if I could do some solder work for him. I said, yeah, sure, not a problem. And I said, only got one request of you. And he goes, oh yeah, what's that? Here's my request. This is the lid. It's got this cool little smiley face on top. That's awesome. But that's not what a customer is going to want to have on this piece of equipment. So, my friend happens to own the largest metal supply warehouse in town that wanted me to do this solder work. And I said, dude, I need you to bust me out a new lid. So he busted me out a brand new 40 thousandths thick lid that's polished with nothing on it, and it's clean, and it will go directly on this thing. Of course, I'll go put it on the sander, and I'll put a little bit of a bevel to each one of these edges. That way nobody can hurt their little delicate skin. You know, round out the corners and put the appropriate bevel on it to make it look 100% stock. So when you get it, there's a plastic film that's on the outside of this, and I will leave that on here. Well, no, I'm going to pull that off. I'm going to sand it so it looks stock. You know, take like some 200 grit sandpaper or whatever to it and make it look stock. And yeah. So now that we've got the lid covered completely, I've already got a guy that called me yesterday, and he's interested in this particular amp because he's got himself a high output derail radio. Well, he was interested in a 4-pill box, and I said, okay, I have none that I can sell you at this very minute. He goes, oh, I said, I'm too busy. I cannot take your money or your order for a 4-pill box. What I can do is I've got this messenger that's sitting here that has the driver's section removed, which you can easily put like a striker into this. Okay? So what we're going to do is we're going to perfectly set this up to take like a derail striker, a high drive 90 watt radio, to run this amplifier. And I think this will be well within his electrical constraints for his vehicle as well. So, let's get headed in that direction. I know it's Saturday. I don't normally return calls on Saturday. I'm just trying to stay ahead of the mess. Please feel free to give me a call on Monday. It's 208-392-0108. Thank you. I just sat down and returned 20-something phone calls. It's Saturday, you guys. I'm actually closed. Now let me show you something. This is how I check my voicemail right here. And this is no joke. I cannot sit down and listen to all the voicemails I got. Now, yes, I know my mailbox is full. See, it says, BBI, your mailbox is full. Look, I don't listen to voicemails, but people expect to be able to have a voicemail box to talk to so they can tell why they called. I just return calls. That's all I do. So we're going to go to the inbox. We're going to go to hit the delete button. We're going to go select all, and then we're going to delete. That saves me about 3 hours a day by not listening to voicemails. Mailbox is empty. I clean my mailbox out when I get up in the morning, and I clean my mailbox out when I go to bed. And it usually fills up before noon almost every single day. The phone management costs more time than the work. It's amazing. Well, shit, today's Saturday. I got a customer coming to town. I got to do an install on his stuff. It's 6 o'clock in the evening. He's not going to be here for another 2 hours. We're going to take advantage of the fact that the sun up here doesn't go down until about 9 o'clock in the evening. So here we are on our little Messenger. I took it out, I washed it. And it's like I was discussing, we're going to leave this driver section bypassed. But before we go and we put power to it, put power wires in here, do the power wire upgrades and stuff. I did remove the power wires just here a little bit ago. We've got to replace these caps, which are not the appropriate value or size. Let me pan in here and we'll take a look at it. Those little tiny disc capacitors will just break down underneath the pressure. So, according to the book, and to my little brain, these need about 500 puff worth of capacitance. Well, I'm not going to put 500 puff metal clads on here. I could, I guess, but the book calls for 430 puff. So we built up a 430 puff, and this is exactly 430 puff a piece. But what we're doing by using 3 capacitors is we're spreading out the voltage rating that's going to be applied to these. And we're making it across 3 separate components. So we can take 3 500 volt rated components, and then we can put it into a 1500 volt environment, 15 kVA, or not 15 kVA, 1.5 kVA environment. All these capacitors do, there's about 14 million names for what this part is. It's a swamping capacitor. It swamps the resonant field of the output of the shmoo lickum penis. Okay. If you take and we stack up standardized beads, each one of these beads is standard in size, okay? If you've got $1 million to burn, you can go out and have Amidine or one of those big companies like that take some of their powder cake and make you your own core size, okay? Like ICOM and Kenwood and Elenco, those big companies, they go and they either, if they don't have something that's on the shelf for exact resonance, that's already in the book that they have produced, they just have the product made that they need. When you're trying to achieve the coupled resonance of this transformer, I'm going to get technical here for a minute, and I'm going to use big words, which I freaking hate. I can't stand people that try to talk big and sound like they're smart, because I have to use big words for this next little bit, but that doesn't mean I'm smart by any means. I'm a functional retard. There's a delicate balance that takes place as far as resonance coupling, okay? And how we achieve our resonance coupling is by the number of turns versus the length of the transformer over the face of the transformer for the frequency. Well, nothing is exactly spot on. So how we get there, how we achieve the direct coupling resonance that we need out of this transformer, is we add capacitance here, which adding capacitance has a tendency to make the electrical field that's taking place on this transformer think that the transformer is longer or the face is bigger, okay? That's what allows us to change the impedance that's taking place inside this transformer to be something as close to being resonant for us. Those are all lots of really big fancy terms. Basically what we're doing is we're making it so that this circuit is happy when this circuit's trying to run, the transistor. Okay. This is called a bifilar winding. Yeah, bifilar. Now, here's one I dug out of oh, no, it's hanging to the wall. Yeah, never mind. I got it screwed up here in the wall. I've got a 9-to-1, they call a 9-to-1 coaxial coupling device. And that uses 4 turns of 12.5 ohm coax to achieve our 50 ohm field, or our 50 ohm resonance that we're trying to achieve. I was going to explain to you how that works as well, but that's only really been embraced in the LD MOS community and the MOSFET community, because we're trying to achieve this huge field of resonance between 0 megahertz and 30 megahertz, so 0 and 30. To make a transformer that's naturally resonant across all of those things is really hard to do. So you can achieve a resonant thing like that by using a 9-to-1 coaxial based unit. There's a reason that when we have 8 transistors in a box like this, and they're trying to make an amplifier work, let's say for the amateur community, we're trying to make the actual output resonance be somewhat flat, a flat response, all the way across the frequency band. Why there's such a decreased output versus like when we go to some of the monoband boxes. Like if I was to build one of these for 80 meters, just specifically 80 meters, and we had Toshiba transistors in there, we can make it do 2,000 peak watts out of 8 transistors, not oversaturate the device, not oversaturate the transformers, and not cause it to be splattered, because the Q factor of the resonant field of the coupled device, these transformers, is incredibly steep and narrow. Otherwise, where this thing will allow it, the RF to resonate, is only going to allow it to resonate on this much frequency when the whole band is like this big. Not that much. So no other spurious emissions can come from the box. Well, what we're doing here is the number of turns versus the size of the beads over the length versus the face of the transformer totally adds up to a big number, but we're off a little bit. I know for a fact that these caps are not the right ones. So we're going to pull these caps out. We're going to put these in their place. And then we're going to go ahead and finish and do our power wire install. We're going to put a rubber grommet in here. We're going to bring in 4 pieces of 8-gauge wire in the back. We'll probably abandon this eyelet. And we'll probably bring 1 piece of 8-gauge here and another piece of 8-gauge here, which is electrically in the middle. That way there's an even amount of current versus this particular way of feeding it, where these two two-pill banks of transistors are receiving the most ground potential current, and then the ones on the farthest end are starving. Obviously, you know, current's going to flow to the closest direction with the least amount of resistance. Once we overcome the resistance here and here, then these 2 banks actually get current. How we go about splitting that up is we're going to put a power wire here and a power wire here. That means this 4-pill bank and this 4-pill bank will have the same amount of current access to ground, and we're going to do the same thing on the positive side. We're going to abandon this little eyelet here. We are going to put a piece of phenolic in here like they did on the later version messengers, because this is an early version messenger. And we're going to take 2 pieces of positive wire, and 1 here and 1 here. Basically creating the best environment for success with this little guy that we possibly can give it. So now that we're done with all the fancy big words, let's get on with it. Less talky, more do. I love when I have a goal. Very clear goal. Like the guy says, I'm going to take so-and-so's radio, and I'm going to run it into this and this and this. I want you to build something to work towards this. This is all I'm going to do. I love it. Okay, so we went through and we did a bunch of little tweaking. We removed the variable out of the back, which is the worst part of the whole design when it comes to this box, in my opinion. That and the power distribution in it. We removed the little slinky coiled up wire that was over here. Just got rid of it. Went ahead and added a piece of phenolic in here to give it more surface area to carry more current. Then we doubled up on our power wire size. Put nice, long, flexible, soft wire on it. Did the same thing with the ground. Got rid of the single feed point. Broke up our feed points, as I explained in the previous video. Added a little bit of capacitance, just a little tiny bit. Where the capacitance here, everything's settled down perfectly. The drive section is still in here and is completely intact. So literally and not figuratively, all we got to do is take this coax, hook it up here, take this coax and hook it up there, and this box will go back to running 100% just the way it was. Now, because this thing is designed to take a striker, we never want to put it up here in the 4-watt position. Never, ever, ever do I ever want to see your nasty biker boobies ever again. We don't want to run this up in a 4 watt. We want to run this always in the 10 watt position, because the attenuator is still in here. And if you flip this up, it's going to show up is your input tune's going to go crazy. Because a little tiny attenuator that's in there can't take the 100 watt horsepower of the freaking radio. Okay, so let's turn the amp off. Oh, here. Preamp is now working. Turn the volume back down on this thing. So we're on a 1,000 watt slug in peak. 1,000 on average, 5 watt slug in reverse. Oh, wow. About 80, 90 watts. Okay, peak power. Oh, wow. 750. Oh, wow. About 300 bird. Wow. To make the SWR bridge in the Striker happy is a lot harder than most people think. It is a challenge. Very big challenge. So now that we've opened this thing up, got to remember this has got, as I said in the other video the other day, and it was brought to my attention by a phone call here this afternoon. I must have been exhausted the other day when I shot the video. Genuine Motorola SD1446s in it. This has got 1446s in it, or 455s, MRF 455s in it. So 455s, 8 of them, getting 750 to 800 watts out of it. That's the most you're ever going to get out of these transistors. You're going to get the most flat response that you can across the entire band. It's biased for sideband. It'll easily take the drive of the Striker and keep on chooching. Audio. 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. Okay. That was the mic and a half. I wonder if it'll pick up any. Hello. Hello. No, it won't. Look. Now we've got the other elephant in the room that we have to sit around and talk about. If we look, you'll find that this mid-rib down the middle of the heatsink is the hottest, and out here towards the edges is the coolest, because all our transistors are clustered down these couple fins. So, because no air can flow across this thing, most people set the amp just like this and then they run it. Oh no, it's good, man. It's horrible. We're going to fit up our new brushed, cleaned up lid. We're going to fit that to this thing. It's the last time we're going to see the inside of it. Pretty, isn't it? And then we're going to make it so that the amplifier sits like this from now on with rubber feet on the lid. Maybe people will get a clue. And we're going to mount up a fan. We're going to put a single 120 millimeter fan on here, which is going to move a whole lot of air across these little tiny fins, and it's going to get the job done and make it so it can run forever and ever. As long as you don't go do anything silly and try and drive like an SRF 490 or something into it. I mean, I guess you could get away with doing a 490 or a 497 with a fan. Definitely want to have a fan. So, leaving no stone unturned and not wanting to make sure anything is done half-assly around here, let's put a fan on it. This fan scares me. think that might be a little much. This is like a 300 and something CFM, 120 millimeter Delta fan. Pulls only 3.5, 4 amps though. This fan scares me, like, a great deal. And it's even got slotted venturis on the input to help get the air spinning in the right direction. That might be a little bit too aggressive for this situation. Hold on. Okay, slow down there, hot rod. I just killed that fan. Nope. I don't know, it might be a little too aggressive. Enough silliness. Incredibly loud. Can you imagine listening to that in your truck all day long? Now, I think a more appropriate option would be this little guy here. This is a half amp, 12 volt standard, little brushless, made by Delta fan. And we're going to hook it up on 14 volts. Of course, it'll turn even slower than this once we get it in the amplifier. Most of the electronics these days in these fans are so shittily put together that we found that we've got to lift the ground on them. And that guy's real quiet, and it's still moving a substantial amount of air, but it's not going to give you a migraine. And it's enough to help get rid of the heat. So now I've cooled the heatsink down from 100 billion butthole degrees. Kind of like Phoenix, Arizona, 2 inches from the taint of God's ass. 100 million degrees. Hello. Now we're getting closer to 800 watts out of it. Hello. 1 2 1 2 1 2 1 2. Hello 1 2. Hello, 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. The only thing that's getting warm now is the center kind of rib of heat sink. Hello, 1 2 1 2 1 2 1 2 1 2. Hello, hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. I so wish I could. I need to save the money up and buy a higher resolution handheld FLIR. Oh, 1 2 1 2 1 2 1 2 1 2. Oh, or I just need to quit being lazy and maybe turn my channel into a Patreon channel. But I like the fact that I can put any kind of content on any level about anything, saying anything I want about anything, using any kind of language I want anyway. And the worst that's going to happen is maybe YouTube might get upset with me. I don't have to worry about Patreon coming along and taking control of my channel, which has been a thing on some other YouTube channels. But then again, I'm not like microwaving flies and showing people how to build pipe bombs in their basement. But this is what it is. I think this fan will do. We'll go ahead, we'll hook it up by 2 standard attachment points, put a little fan guard on it, wrap some wires around so it's hooked onto the power wire. I think we'll be done. I just sanded all the garbage off the side of the heatsink. I got the fan installed. Now I'm doing the new lid. I sanded all the garbage off the side, and look at what's scratched right down here on the heatsink. It says 421-1992. Wow, okay. Jeez, almost 30 years later. I remember 1992 like it was yesterday. Man, a long time ago. I was dating this girl named Sabrina. God, she was cute. Whew. But I think most of us are when we're in our early 20s or early or late teens, you know, like 17, 18 years old. Beautiful people. Young, beautiful, and full of life. Anyhow, it's crazy. Almost 30 years later. Anywho, signed. Let's get the tin on it and let's wrap this puppy up because we're done. This thing is done. Fartsy shots. That's all I'm going to say. New lid, ready to rock and roll. This thing has got to go to a new home. I've had several people call me and come talk to me about this amplifier. It is done. Ready to go on to some other place, be with someone of the one, and get talked on no matter where they're going to talk on it. Makes no difference to me. Cleaned up pretty tight and neat. And we're not talking like shaved the bush down far enough that we didn't lose our car keys in it no more kind of neat. We're talking clean, mean, and ready to go. So you guys know the routine. I want $800 for this thing, plus the ride. Call this number right here. We'll get you squared away. Guys, I got to get, it's middle of the afternoon. I got a bunch of stuff I got to get done today. Got a bunch of stuff going out, and I got a bunch of customers I got to take care of, and a bunch of phone calls I got to return. So on that note, give me a ring if you're interested. It's all fixed up. Ready to go. I'll see ya. Bye.